you lovely people. Welcome back to another exciting video on probability. Today we're talking about the difference between experimental probability and theoretical probability. So let's dive in. Experimental probability is what actually happens when you do something, right? So you flip a coin, you spin the spinner, you choose the socks from the drawer, you choose the pieces of candy. So with experimental probability, it's what actually happens when you do something, right? What actually happens. Theoretical probability is what should happen, right? In theory, right? So if there's 8 colors on a spinner, there's only one of each, you should land on each color 1 out of 8 times in theory. So experimental is what actually happens when you do something. Theoretical is what should happen in theory when you actually, when you're looking at that an event, right? Sorry, I didn't explain that last part, right? I had a little, what we call a brain fart. All right, theoretical, what should happen, experimental, what does happen. Okay, so let's talk about what will this actually look like when I'm practicing. So here's a word problem, right? Probability, lots of word problems. So let's look at a word problem to see what we're talking about here. So it says, Aaron flipped a coin 10 times and it landed on heads 7 out of 10 times. So his experimental probability of landing on heads was 7 out of 10 times, which means he landed on tails 3 out of 10 times. So that's just like little notes we can make to ourselves. It says, what is the difference between the experimental and the theoretical probability of Aaron's flips? So the difference means what? The difference means subtraction, right? So if we're looking at the difference between the actual amount of times that he landed on heads versus what should have happened, right? In theory, we subtract those two things. So when Aaron actually flipped the coins, it landed on heads 7 out of 10 times. But let's think about a coin, right? A coin has 2 sides. It has heads and it has tails. So in theory, the probability that it lands on heads should be 1 every 2 times. There's 2 choices. One of them is heads. So 1 out of 2. So we're going to take what Aaron did minus what should have happened in theory. Now we got to think back a little ways to subtracting fractions. When I subtract fractions, I need common denominators. So 10 would be the least common denominator with 2 and 10. So I'm going to change 1/2 to 5 over 10. That way I have common denominators. And then I do my subtraction. 7 minus 5 is 2, and that denominator stays the same. Well, now I got to simplify my fraction. 2 and 10 are both even numbers, so I can divide them both by 2, which means 1 out of 5. So the difference between his experimental probability, 7/10, I don't know what I just did, guys, 7/10, and what should happen in theory, 1/2, is 1/5, right? So we find the difference between what did happen minus what should have happened. So, right, not too bad, kind of easy peasy. All right, let's look at one more example together. We're going to need to make this a little smaller so I can write. All right, this one says, Kimberly spun the spinner 20 times with the results represented in the table below. What is the difference between the theoretical probability and the experimental probability of her spins for red? So let's look at in theory, theoretical probability. The probability I land on red, and we're assuming that these 3 are red, right? So let's count how many pieces there are. 1, 2, 3, 4, 5, 6, 7, 8 pieces. 3 of them are red. So in theory, she should land on red 3 out of 8 times. But when she actually did her 20 spins, she landed on red 4 times. So 4 out of 20 times. All right. Okay. So let's think of, we need a common denominator between what we could do. We could make these percents and then subtract the percents. Or we could keep them fractions and find common denominators and do all that fun stuff. Let's keep them fractions just to kind of get going with what we need to do. All right, so least common denominator probably would be 40. All right, so 8 times 5 is 40, so I multiply the top by 40. So 15. 40 here, that's times 2, so I multiply that by 2. And let's see, so 15 minus 8, well, you know that one is 7. So 7/40ths would be the difference between theoretical probability and experimental probability, right? What should happen minus what did happen. So notice on both of these, on these two examples, the first one, we found the difference between experimental and theoretical. What did happen minus what should have happened. So the word problem is going to tell you the order in which you should subtract usually, right? But normally it's just big minus little. But this one, it was theoretical and then experimental. So again, telling us the order. Take the theoretical minus the experimental for the second one, experimental minus theoretical for the first one. So just pay attention, just make sure you're paying attention to those little like kind of things. So remember, experimental, what does happen, theoretical, what should happen. When you're finding the difference between those two, take the bigger one minus the little one, find that difference. All right, let me know if you have any questions. Love ya. Bye.